All right, welcome back. So I've been enjoying this book, uh, AI Engineering Building Applications with Foundation Models by Chip Huyen. Last video, really awesome link that I added in my LinkedIn. I think I put it in the description of the video as well. Um, it's a link to all of the, yeah, I put it right here. So it's updated every 12 hours, presumably by some sort of automation. And basically, anytime someone writes out a tool, and 2025 is going to be the year of the agentic tools. So keep an eye out on this list for all the new agentic tools that are going to be coming out. And then the cool thing is too, you can kind of learn like who these devs are too. Um, there's so much information on this list. It's pretty awesome. So we can add a condition here. We can see where the repo contains. Um, let's see here. A Oh, so that would be for the name of the repo. So let's not do that one. So let's do okay, so we can hide a field. So yeah, let's instead of the repo, let's do the category. And the category is aha. There we go, perfect. So the category, um let's do tutorials for the category because that would be a good thing to do next after this. It's just these are all tutorials for learning. So and then the devs are all listed there. So now let's sort it by by number of stars. Okay, so we've got a tutorial there with we've got a tutorial there that uh 66,000 people on yeah, 66,000 people have taken this tutorial, and looks like it's from Microsoft open source. So generative AI for beginners. This will give you everything you need to know to start building generative AI applications. So look at that. Doesn't get any better than that. Now you know kind of what the crowd is doing, and you can follow the crowd, or you can kind of go against the crowd. Let's look at the one with the fewest number of stars. Um, so the fewest number of stars, we've got oh, awesome, Crew AI. So Crew AI is a really cool tool. Um, it's an agentic tool. Yeah, here's some experiments with it. Cool. Okay. Yeah, and you can just get like people's notes. So that's one thing I would recommend doing with this is like figure out like who these people are and like follow the leaders of the field. When I read situational awareness, there was an AI researcher that Leopold Aschenbrenner basically like fawned over. So like this revolution is going to be led by definitely some key players. So kind of pinning those people down and seeing their work that they make public, I think would be a pretty awesome thing to do. But anyway, moving on. So let's continue reading the book. Chapter 2, Understanding Foundation Models. To build applications with foundation models, you first need foundation models. While you don't need to know how to develop a model to use it, and I'll do a sound check because it's like these videos do not have sound. All right, a high level understanding will help you decide what model to use and how to adapt it to your needs. Training a foundation model is an incredibly complex and costly process. Those who know how to do this well are likely prevented by confidentiality agreements from disclosing the secret sauce. This chapter won't be able to tell you how to build a model to compete with ChatGPT. Instead, I'll focus on design decisions and consequential impact on downstream applications. With the growing lack of transparency in the training process of foundation models, it's difficult to know all the design decisions that go into making a model. In general, however, differences in foundation models can be traced back to decisions about training data, model architecture and size, and how they are post-trained to align with human preferences. Since models learn from data, their training data reveals a great deal about their capabilities and limitations. This chapter begins with how model developers curate training data, focusing on the distribution of training data. Chapter 8 explores dataset engineering techniques in detail, including data quality evaluation and data synthesis. Given the dominance of the transformer architecture, it might seem that model architecture is less of a choice. You might be wondering what makes the transformer architecture so special that it continues to dominate. How long until another architecture takes over? And what might this new architecture look like? This chapter will address all of these questions. Whenever a new model is released, one of the first things people want to know is its size. This chapter will also explore how a model developer might determine the appropriate size for their model. As mentioned in Chapter 1, the model's training process is often divided into pre-training and post-training. Pre-training makes a model capable but not necessarily safe or easy to use. This is where post-training comes in. The goal of post-training is to align the model with human preferences, but what exactly is human preference? How can it be represented in a way that a model can learn? The way a model developer aligns their model has significant impact on the model's usability and will be discussed in this chapter. While most people understand the impact of training on a model's performance, the impact of sampling is often overlooked. Sampling is how a model chooses an output from all possible options. It is perhaps one of the most underrated concepts in AI. Not only does sampling explain many seemingly baffling AI behaviors, including hallucinations and inconsistencies, but choosing the right sampling strategy can also significantly boost a model's performance with relatively little effort. For this reason, sampling is the section that I was most excited to write about in this chapter. Concepts covered in this chapter are fundamental for understanding the rest of this book. However, because these concepts are fundamental, you might already be familiar with them. Feel free to skip any concept that you're confident about. If you encounter a confusing concept later on, you can revisit this chapter. Training data. An AI model is only as good as the data it was trained on. If there's no Vietnamese in the training data, the model won't be able to translate from English to Vietnamese. Similarly, if an image classification model only sees only animals in its training set, it won't perform well on photos of plants. If you want a model to improve on a certain task, you might want to include more data for that task in the training data. However, collecting sufficient data for training a large model isn't easy, and it can be expensive. Model developers often have to rely on available data, even if this data doesn't exactly meet their needs. For example, a common source of training data is Common Crawl, created by a nonprofit organization that sporadically crawls websites on the internet. In 2022 and 2023, this organization crawled approximately 2 to 3 billion web pages each month. Google provides a clean subset of Common Crawl called Colossal Clean Crawled Corpus, or C4 for short. I'm going to take a look at this just briefly here. So that leads me to a paper here. And the coolest thing about all this is this ARXIV. Everything's just out there. Like you just click on it and you get the full paper. Like that's rare in silence in science. That's why they did that's why they did Sci-Hub is actually to get access to paper. So like yeah, I don't know where that subset is. Well, anyway, moving on. The data quality of Common Crawl and C4 to a certain extent is questionable. Think clickbait, misinformation, propaganda, conspiracy theories, racism, misogyny, and every sketchy website you've ever seen or avoided on the internet. Yeah. A study on the Washington Post shows that the 1,000 most common websites in the dataset include several media outlets that rank low on NewsGuard's scale for trustworthiness. In lay terms, Common Crawl contains plenty of fake news, so it just has whatever. And that's the thing you got to realize about like fake news too, is oftentimes the people that want you to see misinformation and disinformation are really good at getting a bullhorn, right? So like when a lot of the times the way they get you to see their scams or whatever they're trying to do is they just flood the zone. They put up a giant billboard right in front of your house and you can't turn your head away. So oftentimes their strategy is to flood spaces with their own stuff. So even though you're seeing a lot of yeah, so even though you see a lot of messages out there, you're not getting a diversity. Even though there may be a billion websites out there, half of them might be from one person trying to convince you of something for malicious reasons. So you're really not getting a very diverse uh, diet of information, even though there's an abundance of it. It's all coming from a handful of sources that are trying to exploit you. All right, so here's kind of a ranking thing. I like media bias fact check. There's also ground news. Media bias fact check is free. You just go on and look at and you can pretty easily yeah. So you can just search. So let's search for like CNN. Uh, N. Oh, it's not. Okay, too many N's. Yeah, search for that. There we go. Bias and credibility. There we go. They say it's left of center, mostly factual. So high credibility, so pretty good score for that. Let's do Fox next. Uh, uh, I don't know if this is the same thing. So this is a news reliability rating. I don't know if that's the same as a media bias fact check. And then the other thing is this one's not free. So I like the free one. Ground News is another one that's not free as far as I understand. But Ground News, I like Ground News because you can see like here, like you know, this was yeah, this is a blind spot. This story is disproportionately reported by the left or right. So some Democrats said to be open to backing JFK Jr. is news to most Democrats, and then thousands protesting against Slovakian PM is news to most Republicans. So some of them kind of make sense because like if they're reporting on like what Republicans are doing, the Republican media probably would report that better, um, because they're more tapped into the apparatus and they have tighter sources and stuff. So yeah, I like ground news. Oh, so but media bias check, fact check is amazing. I love it. So Fox News is a questionable source, and they'll explain exactly why. So because they report on conspiracy theories, pseudoscience, propaganda, poor sources, numerous failed fact checks, very low credibility. Yep, and they were sued for defamation. Um, yeah, they some of their biggest programs had to be disposed due to the lawsuit because they were um, making false claims and conspiracy theories against the company. Yeah, so this is my favorite one. It's all free. It's all out there. Um, uh, so overall, yeah, and they give you a clear explanation. So um, promotion of propaganda, conspiracy theories, pseudoscience, use of poor sources, and numerous false claims and failed fact checks. So there you go. Anyway, moving on. So yeah. So what if you get an LLM that's only trained on Fox News and nothing else? Can you guess what the LLM's going to tell you? So Common Crawl is going to contain a lot of that, and so you have to put it up against something, right? Like the data matters. So like you should run it through somehow like media bias fact check and like give it like a score or some sort of bias level or some sort of like, oh, should you take this with a grain of salt? And then, at the same time, if you just completely skip all those resources, there are some um like you could potentially put yourself in a bubble. And as we saw on ground news, you know, there are some stories that are just completely not reported on one side or another. Yet, simply because Common Crawl is available, variations of it are used in most foundation models that disclose their training data sources, including OpenAI's GPT-3 and Google's Gemini. I suspect that Common Crawl is also used in models that don't disclose their training data. To avoid scrutiny from both the public and competitors, many companies have stopped disclosing this information. So there you go. Now you have no idea what they even trained on. Some teams use heuristics to filter out low quality data from the internet. For example, OpenAI used only the Reddit links that received at least three upvotes to train GPT-2. While this does help screen out links that nobody cares about, Reddit isn't exactly the pinnacle of proprietary and good taste. And then the other thing is like I follow like r/violin r/viola. Like a lot of the times what you get is like a kid in high school saying, "Help me out with this fingering," and like it doesn't get traction. Like popularity is not at all, you know, t reflective of relevancy and quality in a lot of cases. Like a post on Reddit's going to go get popular if it's sensational, if it's eye-catching, a kid asking for what fingerings make sense in this passage of 20 bars that they're playing in their orchestra. I'll just tell them, like use third position and whatever, and like they might upvote me, but I'd be lucky to get one upvote, and then the professional or some a-hole is going to come and downvote me to oblivion for no reason because they're like a sociopath. So it's like, it has nothing to do with popularity, whether or not the advice is good. So like popularity is not a good metric for like really good advice. Like really good advice oftentimes is one-on-one. Like when you see a therapist, you go in one-on-one. You don't get your therapy voted on. So like, yeah, it's hard. It's hard. The use what we have, not what we want approach may lead to models that perform well on tasks present in the training data, but not necessarily on the tasks you care about. To address this issue, it's crucial to curate datasets that align with your specific needs. This section focuses on curating data for specific languages and domains, providing a broad yet specialized foundation for applications within those areas. Chapter 8 explores data strategies for models tailored to highly specific tasks. While language and domain-specific foundation models can be trained from scratch, it's also common to fine-tune them on top of general-purpose models. Some might wonder, why not just train a model on all data available, both general data and specialized data, so that the model can do everything? This is what many people do. However, training on more data often requires more compute resources and doesn't always lead to better performance. For example, a model trained with a smaller amount of high quality data might outperform a model trained with a large amount of low quality data. Using 7 billion tokens of high quality coding data, um, the researchers of that paper in 2023 were able to train a 1.3 billion parameter model that outperforms much larger models on several important coding benchmarks. The impact of data quality is discussed more in Chapter 8, and that's an important thing to understand. When you hear in the news, oh, it's hit a data wall, AI's at a halt, well, they don't need more data. Like, they've got all the data they could possibly need. What they need is high quality data. They need to um, so it doesn't matter if we hit a data wall. Like we're not even using the data we already have effectively. Multi multilingual models. And this is cool too. One of my favorite things I've been doing lately with my $200 a month, my subscription to ChatGPT. Hola, ¿cómo estás?
Hola Graham, estoy bien, gracias. ¿Y tú? ¿Cómo te va hoy?
Muy bien, gracias.
Me alegra oírte bien. ¿En qué puedo ayudarte hoy?
Sí.
Perfecto. Si necesitas algo, aquí estoy.
Adios.
Adiós, Graham. Hasta luego.
Yeah, like you can like it can teach you the languages. Like it's so cool. And like yeah, it's so cool. Guten Nachten.
Guten Abend. Wie kann ich dir heute helfen?
Nein.
Alles klar. Wenn du doch etwas brauchst, bin ich hier.
Alles klar.
Perfekt. Genieß deinen Abend.
Yeah, so it can just like it doesn't have to. It's not limited to English, and it can teach you like it's crazy. It's what a world we live in. All right, so multilingual models. English dominates the internet, and analysis of the Common Crawl dataset shows that English accounts for almost half of the data, 45.88%, making it 8 times more prevalent than the second most common language, Russian. Wow, which is only 5.97%. That's crazy. See Table 2-1 for a list of languages with at least 1% in Common Crawl. Languages with limited availability as training data. Typically, languages not included in this list are considered low resource languages. So yeah, like these low resource languages, I would even call them endangered languages, because if we go forward and you want to learn a language through your LLM, it's not going to have a lot of languages. So the number one is English, and then number two is Russian. Um, uh, but the difference between, look at this, 46% versus 6%, like, and then the next one, oh, the next one's German. That's interesting. Okay, English, Russian, and German. That's interesting. Okay, I didn't know that. Well, cool. That's a cool collection of languages to know. Those might be my languages, because I learned Spanish in school, but Spanish is kind of low on the list. It looks like, yeah, English, Russian, and German are up there. Um, yeah, and then very quickly, we get below the one mark after just like, not many more than 10 languages. We got two there, 10. Yeah, so like less than 15 languages. Now we're down uh, in an amount of training data where the languages basically don't even exist on the internet at all. And there's some big languages missing. Like, so we got English, Russian, German, Chinese, Japanese, French, Spanish, Italian, Dutch, Polish, Portuguese, Vietnamese. So like, where is Ukrainian? That's the biggest. The whole conflict there. Part of it is a battle of languages. And so, according to the AI, who's going to win that battle going forward? Like, Russian is all it has to. So somebody from Ukraine who really cares about, the Ukrainian language, better find a way to have Ukrainian get picked up by Common Crawl, um, more than Russian, and they're pretty far behind because Russian is the second most common one. So, this is uh, significant, which languages are on there and which languages are not. And yeah, there's I feel like, yeah, the big one that's missing is the Indian languages. So what's oh what is the so what is the most common language spoken in India besides English, I should have said. But like, that's surprising that that's not on there. So, oh, is it not on there? Huh, that's really surprising. That would be like, would Hindi, or is that a, I don't know, we'll see, we'll see. Hindi, yeah, I was right. Yeah, it'd be Hindi. So like, that's noticeably absent, is Hindi. Um, so yeah. Many other languages, despite having a lot of speakers today, are severely underrepresented in Common Crawl. Table 2-2 shows some of these languages. Ideally, the ratio between world population representation and Common Crawl representation should be 1. The higher this, yeah, exactly. The higher this ratio, the more underrepresented this language is in Common Crawl. So Table 2-2, examples of underrepresented languages in Common Crawl. The last row English is for comparison. The numbers for percent in Common Crawl are taken from this research paper here. So let's go to that. So these are our, so yeah, oh, this is fascinating here. So look at this. Yeah, I was right. So Punjabi um is is a big one that is missing from the list. There are 113 speakers of Punjabi. Um, More than 1% of the world's population, 1.4%, are there speak it. But it's basically completely missing from Common Crawl. So these 100 million speakers, they're not going to be able to talk to the LLM unless they learn another language. Yeah, so a world population of 8 billion was used for this calculation, which is an undercount. The population is much higher. It's 9 billion. Really? 2022. Oh, okay. I thought it was 9 billion. All right, well, 8 billion. Given the dominance of English in the internet data, it's not surprising that general purpose models work much better for English than other languages, according to multiple studies. For example, on the MMLU benchmark, a suite of 14,000 multiple choice problems spanning 57 subjects, GPT-4 performed much better in English than underrepresented languages like Telugu, as shown in figure 2-1. All right, so GPT-4 three-shot accuracy. So this is giving it three examples and then seeing if it can take those and run with it. So with random guessing, 25. Yeah, so it does better in English than it does in other languages. We can see the number goes down the more uh, the language is missing from Common Crawl data. And there's some languages that are very widely spoken that um, just aren't present in that Common Crawl data. All right. So figure 2-1 on the MMLU benchmark, GPT-4 performs better in English than in any other language. To obtain MMLU in other languages, OpenAI translated the questions using Azure AI Translator. That's interesting. Similarly, when tested on 6 math problems on Project Euler, uh, Jenny Huyen found that GPT-4 was able to solve problems in English more than 3 times as often compared to Armenian or Farsi. GPT-4 failed in all 6 questions for Burmese and uh, Amharic, as shown in figure 2-2. GPT-4's pass rate for these questions pass and fail, so very good. Yeah, so uh, yeah, interesting. I'm surprised it doesn't do better in Russian because Russian was the number two on Common Crawl. So I would have expected it to be English, Russian, and German, but it looks like Modern Standard. Oh, it looks like Arabic is number two. That's fascinating. Okay. Arabic was another big one that was noticeably absent from the Common Crawl. All right, moving on. So figure 2-2, GPT-4 is much better at math in English than in other languages. Underrepresentation is a big reason for this underperformance. The three languages that have the worst performance in GPT-4's MMLU benchmarks, Telugu, Marathi, and Punjabi. The Punjabi is what is Punjabi? Okay, Afghanistan, Pakistan, and India. Yeah, that's what I was thinking is like that area of the world seemed to be very underrepresented in Common Crawl. So yeah, it's Punjabi would be the big one that's missing from there. Probably even bigger than Hindi. Let's check back in and see if that makes sense. What about Punjabi? Oh, now it's got to think about it for 1,000 years. All right, moving on. Okay, are also among the languages that are most underrepresented in Common Crawl. However, underrepresentation isn't the only reason. A language's structure and the culture it embodies can also make a language harder for a model to learn. Given that LLMs are generally good at translation, can we just translate all queries from other languages into English, obtain the response, and translate them back into the original language? Many people indeed follow this approach, but it's not ideal. First, this requires a model that can sufficiently understand underrepresented languages to translate. Second, translation can cause information loss. For example, some languages like Vietnamese have pronouns to denote the relationships between two speakers. When translating into English, all these pronouns are translating into I and you, causing a loss of relationship information. Models can also have unexpected performance challenges in non-English languages. For example, NewsGuard found that ChatGPT is more willing to produce misinformation in Chinese than in English. In April 2023, NewsGuard asked ChatGPT 3.5 to produce misinformation articles about China in English, simplified Chinese, and traditional Chinese. For English, ChatGPT denied to produce false claims for 6 out of 7 prompts. That's interesting. However, it produced false claims in simplified Chinese and traditional Chinese all 7 times. That's really counterintuitive. It's unclear what causes this difference in behavior. You'd think that in English, the language that's not native to it, it would be that one would produce more false claims because you'd think there'd be more false claims in English than there were in. That is interesting. I don't know how that works. Looks like I accidentally highlighted this, so I'll get rid of my highlight. Huh, that is fascinating. Let me read the source a little bit here. So, NewsGuard exclusive generates more disinformation in Chinese than English. Okay. Uh, China-related myths. Oh, that's interesting. So they had it verify 7 myths about China, and these a myth is a statement that many believe to be true, but in fact is false. But the thing is, in English, this misinformation about China was detected, but in Chinese it wasn't. So it's like if you think of an English speaking versus a Chinese speaking person, you would probably think the opposite would happen. The person who knows about China so well that they actually speak Chinese would be able to detect these myths and debunk them as false. But very counterintuitively, it looks like the opposite happens to ChatGPT. So that is pretty fascinating. I wish I could see what the claims were, just because I'm interested. Huh. Well, that is interesting. Anyway, moving on. Other than quality issues, models can also be slower and more expensive for non-English languages. A model's inference latency and cost is proportional to the number of tokens in the input and response. It turns out that tokenization can be much more efficient for some languages than others. Benchmarking GPT-4 on Massive, a dataset of 1 million short texts translated across 52 languages, Yenny June found that to convey the same meaning, languages like Burmese and Hindi require a lot more tokens than English or Spanish. For the massive data set, the median token length in English is 7, but the median token length in Hindi is 32. And in Burmese, it's a whopping 72, which is 10 times longer than in English. So you have to pay to use tokens when you use the API. So all these people are completely priced out of using AI as well as if they weren't already. Even if it were 7 or less, they'd be priced out. But they gotta pay even more to use their native languages. Assuming that the time it takes to generate a token is the same in all languages, GPT-4 takes approximately 10 times longer in Burmese than in English for the same context. For APIs that charge by token usage, Burmese costs 10 times more than English. To address this, many models have been trained to focus on non-English languages. In the most active language other than English is undoubtedly Chinese, with ChatGLM, Yayi, Llama Chinese, and others. There are also models in French, Croissant LLM, that's funny, uh, Vietnamese, Fa GPT, and Arabic. I wonder what this is. Is this a food? JAIS, Jace, and many other languages. Is that a food? Let me see. Uh, oh, I think it's a town. Well, that's too bad. There's not like an Arabic dish. Why couldn't? Oh, there's like they have like some of the best food. Why couldn't they have called it like fava or something? All right. Domain-specific models. General purpose models like Gemini, GPTs, and Llamas can perform incredibly well on a wide range of domains, including but not limited to coding, law, science, business, sports, and environmental science. This is largely thanks to the inclusion of these domains in their training data. Figure 2-3 shows the distribution of domains present in Common Crawl according to the Washington Post's 2023 analysis. Distribution of domains in the C4 data set. So yeah, we break down yeah, is this really what you want? 11% arts and entertainment. I mean, arts and entertainment, but you know, yeah. So you've got to make sure that your model is domain specific because most likely it'll just be trained on Common Crawl, and Common Crawl contains these domains. And this is the same thing like with the language thing, where there's some domains here that I bet you would really want to be on here that aren't. So we see science and health, that's a good one, but 9%, that's pretty bad. I'm not sure how much I like that, but I mean, I'm sure I can think of a domain that you would want on here that isn't. So law and government, community, travel, home and garden, jobs and education, hobbies and leisure, science and health, business, industrial, technology, news and media, arts and entertainment. So I guess so law and government is on there. That might be like politics. That's a big one that's missing, but it's covered under probably government. Um, I guess I can't really think of any that are missing. Um, you know what? I think. Oh no, jobs, education is there, but it's only 7%. Figure 2-3 distribution of domains in the C4 dataset reproduced from the statistics from the Washington Post. One caveat of this analysis is that it only shows the categories that are included, not the categories missing. Yeah, so we can. So I had trouble thinking of one that. So what's a notable? Let me use ChatGPT for this because I'm just curious. What would you say is the biggest domain that is missing here? Uh, what would you say is the biggest domain that you would think would be on this chart but is not? All right, and as that's going, we can read forward. As of this writing, there haven't been many analyses of domain distribution in vision data. This might be because images are harder to categorize than texts. However, you can infer a model's domains from its benchmark performance. Table 2-3 shows how two models, Clip and OpenClip, perform on different benchmarks. These benchmarks show how well these two models do on birds, flowers, cars, and a few more categories. But the world is so much bigger and more complex than these few categories. So table 2-3, OpenClip and Clip's performance on different image data sets. So data set, we've got ImageNet, ImageNet v4, BirdSnap. So, okay. All right. So even though the general purpose foundation models can answer everyday questions about different domains, they are unlikely to perform well on domain specific tasks. Interesting. Even if, because one of my prompts I would use is act as an expert in the following domain of knowledge, and it can't do that because it's unlikely to perform well on domain specific tasks because it's not trained on data specific to those domains, especially if they never saw these tasks during training. Two examples of domain-specific tasks are drug discovery and cancer screening. Oh yeah, that's a big one that I was probably missing. Drug discovery involves protein, DNA, oh yeah, and RNA data, which follow specific formats and are expensive to acquire. This data is unlikely to be found in publicly available internet data. Similarly, cancer screening typically involves X-ray and fMRI, functional magnetic resonance imaging scans, which are hard to obtain due to privacy. All right, so let's see the big one that's missing according to ChatGPT. So one prominent domain that's missing is sports. Okay, that's interesting. Probably folded under news and media. All right, well, what's one that's likely not folded under some other category? All right, keep going. To train a model to perform well on these domain-specific tasks, you might need to curate very specific data sets. One of the most famous domain-specific models is perhaps DeepMind's AlphaFold, trained on the sequences and 3D structures of around 100,000 known proteins. NVIDIA's Bio uh, Nemo is another model that focuses on molecular data for drug discovery. Google's Med Palm 2 combined the power of an LLM with medical data to answer medical queries with higher accuracy. Tip: domain-specific models are especially common for biomedicine, but other fields can benefit from domain-specific models too. It's possible that a model trained on architectural sketches can help architects much better than Stable Diffusion, or a model trained on factory plans that can be optimized for manufacturing processes much better than a generic model like ChatGPT. This is the stuff that's like really gonna change the world. I actually met a guy who either like had his own or like worked at a biotech company, and he was just like, name something about your body you want to be like better. And like we were all thinking about it, and like the things we didn't even realize, like, because his answer was, I don't want to get scurvy if my body can't produce vitamin C. I want my body to just be able to produce its own vitamin C the way it does the other essential vitamins and minerals. So basically, you can just make your body produce essential vitamins and minerals, and you don't have to worry about deficiencies in the same way. You just take a pill that like makes your body do that. This section gave a high-level overview of how training data impacts a model's performance. Next, let's explore the impact of how a model is designed on its performance. So imagine like you're like me, who's got like a bit of extra body fat, to say the least. I can convert my body fat into like B12 and uh, omega 3, omega 6, like basically just all the any like nutrient deficiency I have, like my body can just like I no longer, the idea of an essential vitamin or mineral is no longer a thing. The body just repurposes senescent cells or body fat into like B12 and vitamin C. Like imagine what a difference that would be. You basically never have a nutrient deficiency no matter what. Like you can still starve, but like you're not gonna have like a nutrient deficiency. All right, so modeling. Before training a model, developers need to decide what the model should look like, what architecture it should follow, how many parameters it should have. These decisions impact not only the model's capabilities, but also its usability for downstream applications. For example, a 7 billion parameter model will be vastly easier to deploy than a 175 billion parameter model. Similarly, optimizing a transformer model for latency is very different from optimizing another architecture. Let's explore the factors behind these decisions. Model architecture. As of this writing, the most dominant architecture for language-based foundation models is the transformer architecture, which is based on the attention mechanism. It addresses many limitations of the previous architectures, which contributed to its popularity. However, the transformer architecture has its own limitations. This section analyzes the transformer architecture and its alternatives. Because it goes into the technical details of different architectures, it can be technically dense. If you find any part too deep in the weeds, feel free to skip it. So I shouldn't have to do that. I've read a bunch of stuff in the past. I read networking for, and I applied for an alternative AGI approach job that involved a lot of reading. So I shouldn't have to skip anything. All right, but I mean, if it's a lot to dive into, it might be good to. Yeah, I think I'm gonna end the video here. It's just going long, and I need to do some grocery shopping to prepare for a potential humanitarian disaster with a deep freeze winter storm 2.0 in Texas. So, yeah, I think this deserves its own video, just starting off with this technical stuff, just so it's not buried. And then it's I'm probably all already at the hour mark, which is typically all I'm good for. Yeah, I'm close to the hour mark. So without like a 10-15 minute break, I'm typically only good for an hour video. So this deep dive into the architecture and the tech, I think is best at the front of a new video rather than buried. So with that, thanks for watching and see you in the next video.